The great thing about travel is it gets you thinking about the area and how did it come to be as it is today. Everything that happens to shape the Earth either happens above or below the ground, and happens on a timescale that's really hard to imagine. But this geological timescale has events that make the Earth what it is today, like mountain building events or orogenies. And one of the most influential of those is the Caledonian orogeny. Over 500 million years ago, the Earth actually existed as two major separate land masses. And when these two came together, along with others, then volcanoes and mountain areas were formed. And the extent of these mountains ran right from Scandinavia, right through north of Britain, and right across to North America. In Britain, the mountain ranges run from northeast to southwest, and even though they've been eroded a lot over the last few million years, evidence of them can still be found in the Scottish Highlands, in the Lake District, and in North Wales. The collision that caused this orogeny also caused faulting of the rocks, and the biggest effect of the Caledonian orogeny here in Scotland is this, the Great Glen Fault.
It may look pretty wintry today, but I only have to dig down probably about 10 centimetres into the snow to uncover bare rock and grass. If I'd have tried this 18,000 years ago, then I'd be digging for a lot longer. In fact, I'd have to dig down 3 miles into the snow, because in the last glacial period, that's how thick some of the ice sheets were. The ice sheets in Britain came down as far south as Bristol, and it would have been perfectly normal to see a giant deer or even a woolly mammoth wandering across a plain. So why isn't it like this today? Well, the climate fluctuates due to a number of reasons, between cold glacial periods where the ice advances and warmer interglacial periods when the ice retreats. Both glacials and interglacials can occur within an ice age, which is just a period of long-term reduction of temperature at the Earth's atmosphere and surface, and this happens at the same time as the presence of extensive ice sheets in the polar regions. We're currently in an interglacial period within the Holocene epoch of an ice age which began 2.6 million years ago. And this is because the Greenland, Arctic and Antarctic ice sheets still exist today. You might be thinking, well, how can global warming be happening when we're still in an ice age? But that's because an ice age is a long-term period, and within this period, interglacials are getting longer. The current interglacial period has seen temperature rises at a rate never seen previously. I find it really hard to imagine if we're thinking that we're in a warm period that's interglacial now. I find it impossible to imagine what it must have looked like when it was glaciated. So it happened about 18,000 years ago. That was when the main peak of the last glacial period was. And most of these mountains here would have been completely buried under snow and ice sheets. In some parts, it was even 3 miles thick. And you just have the highest mountain peaks rising above the ice sheets.
In the future, we don't really know what's going to happen for Scotland in terms of tectonic activity. A lot of this weathering still going on. A lot of glaciation may come back. We're only in interglacial at the moment. The whole Earth is moving. The tectonic plates are moving apart and coming together. And it just means that the Earth will continually be renewed. And as this wears away, we'll get new mountain building events, new orogenies coming through, and we'll get, well, the Scottish Highlands all over again somewhere else.
It's not hard on a day like today when it's absolutely freezing, but come up here in summer and there's not much chance of glaciers ever returning to Scotland. Although we're still technically in an ice age, the interglacial that we're in is seeing temperature rise never seen before, and that's set to continue with global warming.